Before we get into the formal definition of what a cofunction is, let's take just a second to compare the trig function values for angle A and angle B. Here I have written down a problem that we did in our previous lesson. Here I have written down an example that we covered in the previous lecture video, and in that problem we found sine, cosine, and tangent for angle A in this triangle. Then we came back and found sine, cosine, and tangent for angle B of this right triangle that I have represented here. And if I wanted to compare the trig function values for angle A to angle B, I want you to notice that, let's just look at the sine of angle A. The sine of angle A is 36 over 85. And if I compare that over here to angle B, notice that the cosine of angle B is that same 36 over 85. Let's see if that holds true for another angle. Cosine of angle A this time is 77 over 85, and the sine of angle B is 77 over 85. So there is a relationship for the sine of angle A to the cosine of angle B that can come out of this triangle. We know already that the sum of the angles of a triangle are 180. We've defined that this is a right triangle, and therefore we know then that angle A and angle B have to add together to give me the remaining 90 degrees in the triangle. That also tells me that angles A and B are complementary of each other. They are complementary angles. So what do we know? I know that angle A and angle B are complementary angles. I know that the sine of A is the same or equal to the cosine of B, and we can use that information, or in other words, that is the information that is going to define cofunction values and how we can relate them to each other. Let's write down algebraically, let's represent this all algebraically. If I know, using complementary angles, that A plus B is equal to 90, I could rewrite this, solving for angle B, and just represent this as B is equal to 90 minus A. This is just from the fact that we know A and B were complementary of each other. I also know that the sine of angle A is equal to the cosine of angle B. We just said that up there. That was what we highlighted in green. Well, if I know that the cosine of B, I can write this as the sine of A is equal to the cosine of, if B can be written in the form of 90 minus A, then here algebraically I'm representing what is defined as cofunction values of each other. In other words, these would be a cofunction identity. Okay? So here I have a list of the cofunction identities and how they are written for us to be able to use. So sine of A can be represented as the cosine of 90 minus A. And you can just flip that. Since sine and cosine are cofunctions of each other, then we say cosine of A is equal to sine of 90 minus A. And then secant, cosecant are represented in a similar fashion. Tangent and cotangent are represented in a similar fashion. So this is for angle A. We could represent this if I wanted the sine of B equals the cosine of 90 minus B. So I would just change out the angle value that I have written there. Using those cofunction identities, let's see if we can answer these examples down here. The first problem says that I want to rewrite the sine of 9 in terms of its cofunction identity. So let me pull those back up so you can see what they are. So in other words, if I have the sine of 9, which is my angle, then I can rewrite that as the cosine of 90 minus that angle, or the cosine of 81. So in other words, if I have the sine of 9 degrees, that's the same thing as the cosine of 81 degrees. Let's try that one more time with the cotangent. Cotangent of 76 would be equal to tangent, because cotangent and tangent are related, 90 minus 76. So in other words, the cotangent of 76, if I were to plug that into my calculator, is going to return for me the same thing as the tangent of 14. Those two values, if you were to plug it into your calculator, are going to give you back the same thing. Take a minute and you try the cosecant of 45. Okay, so hopefully when you were rewriting the cosecant of 45, in terms of its cofunction, which is secant, you see that it is also 45. That one's kind of a special case, I would say, because 45 degrees, if we're talking between 0 and 90, is halfway in between. So I have 45 here and I have 45 here. Now that's not always the case when we're talking about complementary angles, is it? It's not always cut exactly in half. Notice over here for sine and cosine, here I had an angle measurement of only 9 degrees with the complementary value of 81. So the angle measurements are not going to be the same, but when I take the function value, or when I find the function value of each of these terms, that's what's the same. So the angles aren't the same, but when I actually calculate it, the function value is the same. Okay, so we're going to use that idea down here when we want to solve these equations, which is what we're being asked to do. Find one solution for each of the equations below, and we're going to start here with letter A. I know that cotangent and tangent are both cofunctions of each other, and therefore I know that their angles would be complementary. So I know that let's let cotangent's angle be angle A, tangent's angle be angle B, and remember they're not the same numbers, but because they're cofunctions of each other, their angles are complementary. And if I know that complementary angles add together to give me 90 degrees, then I can just take out what's here in parentheses, what I'm letting be represented by A, which would be theta minus 8. Add that to what is B, which is 4 theta plus 13, and set that equal to 90. Now it's just a simple equation that we're going to simplify. So I have theta plus 4 theta, in other words 5 theta, negative 8 plus 13 gives me a 5, equals 90 degrees, so I'm going to subtract 5 from both sides. 5 theta would be 85, and therefore theta would end up being 17. Okay, so you can see then that we're using the idea, if I know two things are cofunctions of each other, in other words, if I use the definition of cofunctions, if I know these guys are cofunctions of each other, then their angles are complementary of each other. So let's try that again on this particular equation, and I challenge you, go ahead and stop the video and let's come back together and see if we can come up with the exact same answer. Okay, so we're back together and we're taking the idea that secant and cosecant are cofunctions of each other, so therefore their angles would be complementary, or in other words, we would add their angles together to get 90. So simplifying this equation here, I end up with 7 theta plus 6 is equal to 90. Subtract 6 from both sides and I get 7 theta is equal to 84, and therefore theta is equal to 12. So that is the idea behind cofunctions and what it can do for us in finding angle measurements as well, or angle relationships, as well as solving for theta.